My name is Niall Moran, and this is a very quick introduction to QuantEx. QuantEx is a framework for quantum circuits simulation which consists of a number of different Julia packages. At a high level, QuantEx takes a quantum circuit, converts this to a tensor network representation. Then, by representing this as a line graph, it finds an efficient contraction order and then creates a compute graph which can be serialized using a custom DSL format or executed on one of the available backends. I will now show a quick demonstration. Okay, we start the demo by porting QX tools. We can create a circuit for a 60 qubit GHZ circuit, convert this to a tensor network circuit object. We can run flow cutter algorithm for 2 seconds to get a contraction plan. From the contraction plan and the tensor network circuit, we build a compute graph. We then can use context from this compute graph, and then once we have a context, we can perform calculations. So we could have also created a context using GPU data types by passing a Q array as a parameter. We can wrap these serial contexts in a distributed context by using MPI. These work similarly to the way serial contexts work. We can also write a compute graph to a file, and this will then have a list of the load and contraction commands required to perform this contraction. So that's a short demonstration of the QX framework. I'll finish up by talking about what's planned in the future. So to extend the context and add support for distributed.jl and dagger.jl, to improve the sampling approaches, so to add more advanced sampling techniques like rejection sampling, big head sampling, to look at auto differentiation support. Another area of interest is to look at the IR format with a view to standardizing, which would enable interoperability among different packages. And finally, the performance. So continuing to look at opportunities where the performance can be improved, so either by performing optimization passes on the compute graph, by improving the contraction pathfinding algorithms, and also target specific optimizations for specific hardware platforms. Please also check out John Brennan's talk on contraction pathfinding algorithms, and thanks for your attention.